Hey everyone, this is Eric Archer from Texas Instruments, and really excited to be here with chemistry teacher Craig Beals.
Hi, how
And
are you?
tonight we're going to do a question and answer session about the Smart Space video series that Craig did around chemistry. And Craig, I think we did about five lessons. Is that right?
Yeah, we did. We've got 5 videos on there.
That's awesome. And so those of you that are tuning in right now, you can find those videos in the same place you probably found this one, under the TI Calculators YouTube channel. And they're called Chemistry Smart Space videos. We also have those for middle school science as well as biology. There's some physics and some earth and space science lessons. And these lessons are basically meant to give students and teachers some video content. In the days of COVID right now, we're all kind of dealing with, we wanted to make sure we had some resources available to teachers and students. And Craig's going to talk a lot about the chemistry series that we did tonight. So we encourage your questions in the chat. If you would also kind of let us know where you're calling in from. And what the temperature's like there. All right, so get a good sense of if everybody's in Texas kind of heat, or if they're in a northern state enjoying some nice winter weather yet, or some fall weather rather. And then just go ahead and put that in the chat, and then we'll respond to it as we see the questions pop up. We may not get a chance to answer every single question, but please participate in the chat, because Craig and I would love to talk with you, love to answer any questions that you have. Craig, can you tell the audience a little bit about yourself and where you're teaching, and a little bit about your school?
Yeah. Well, first of all, because over here on my other screen, I can see the YouTube chat. And so I need to say hi, because you see a whole bunch of highs. So I know some of those are my students. And so that's really nice of them to show up, because they just had to spend the day with me, and now they're jumping on here. So hello to you guys. I don't have the ability to type right now, but thanks for chiming in. I am Craig Beals, and I live in Billings, Montana. So way up north. Some people don't know where Montana is. We're just a southern suburb of Canada, and we have similar weather to Canada. So speaking of the weather, though, I think you asked, it's like 84 degrees here right now. So it's really nice. We'll probably get down into the 50s or 60s tonight, but fall is here, and things will start to cool down very rapidly up here in the northern climate. I teach at Billings Senior High, which is a public high school of about 2,000 students. To give you an idea of our community, we have 4 high schools here, 3 public, all about 2,000 students, and 1 private Catholic school. So Montana-wise, we are the biggest city in Montana with a whopping 120,000 people, which I know you're in Dallas, which would be a very small suburb of a suburb out in that area.
We have just a few more, but yeah.
Yeah, but this is just the way we like it. We were joking, Eric and I were joking earlier, that we've got at least twice as many, maybe 3 times as many cows out here in Montana than people. And we wouldn't have it any other way. It's great. So I love what I do. I love teaching chemistry. I never intended to be a teacher, especially a chemistry teacher, because I was terrible at chemistry in high school. And I think what that's done is helped me become, I don't want to say a good chemistry teacher, but one that tries really hard to make sure that students understand it, because I understand that struggle. And I know how challenging chemistry can be. And my goal is to really sort of demystify it and engage students with it. And I tell my students every year, I say, look, if you can learn chemistry, you can learn anything. You can learn anything, because we're going to learn a foreign language. Our alphabet's going to be this crazy periodic table. We're going to learn math in the foreign language. And then we're going to go into the lab and try not to blow the whole school up or hurt each other in this foreign language, in the math that you've done in the foreign language. And it's like, that shouldn't happen in 1 year of school, but it does. And then we get to the end and they're like, man, you built this up. I thought this class was going to be hard, but it's not hard if we can break it up into small chunks and help the students really grasp these really, really challenging concepts. And my goal for them is to surprise themselves. I want them to think, man, I did it. Like, I did it. And really, I want them to carry that on with them, that I can learn anything if I learned chemistry.
I think that's just a beautifully well stated goal from any educator, is to help students understand, take complex topics, break it down into smaller pieces. So then you can kind of scaffold, understanding of whatever that topic might be. Chemistry for me was one of the hardest science subjects I'd ever taken, college or high school. And I think it had to do with it just being so abstract. I can't, see it. I can't see what's happening. And when we did those smart space videos, you had a number of examples where you sort of used some hands-on activities to break it down for kids, to make it just the abstract more concrete, so then they can kind of understand what's happening at that molecular level. Can you tell us a little bit about Oobleck and what you did, and moles, and how that whole thing worked out?
Yeah. So in one of the, we did 5 videos, and I'm looking at my list here. We covered dimensional analysis. And I know that I've got students on the chat over there, and they're just rolling their eyes right now, because we have been in deep into dimensional analysis, which really is chemistry math. And once you get dimensional analysis down, I think it makes everything a lot easier. We made a video on moles and understanding how moles play an important role in chemistry and in calculation. We made a video on stoichiometry, balancing chemical equations, and acid base. So I want to go back to the one that you mentioned about moles and Oobleck. So Oobleck is this magical stuff, which is just cornstarch and water. And you play with it, and it's a non-Newtonian fluid, so it's all crunchy, but then it's gooey, and it's everything in between. And if you get the mixture just right of cornstarch to water, you end up with this, this magical substance that doesn't behave like substances should behave. So what we did with moles was take that concept and just present, okay, well, here's the mass, or the number of atoms that you should be using to make this substance, and then taught how moles can be used to then figure out, okay, how do I translate that into something I can do in my kitchen? So how can I take what this very complex thing, how many atoms exist in cornstarch, and then take that all the way to making something out of cornstarch and water by using this one concept called the mole. And so hopefully in that conversation, it gives teachers, if they're watching, and students, if they're watching, sort of a tool to understand this abstract thing, and something to play with at home, because chemistry should be about play. I really think it should be about play. We're like, in my class, we're doing labs nonstop. That's maybe my students are pulling their hairs out with this one as well, because I think it's so important that we do science. To me, chemistry is a verb. Science is a verb. You shouldn't sit there and learn about it. You got to get your hands dirty. And so Oobleck, like you mentioned, is a really good tool to get your hands dirty and learn chemistry at the same time.
That's awesome. And I guess in the chat, I don't know if this is from your students, but they're asking, what's the craziest lab experiment you've ever done?
What's the craziest lab experiment you've ever done? Well, me personally, or in the school?
Let's go with the school approach.
Okay, because well, I don't know about craziest, other than just today we had a fire alarm, so we all had to leave the school. And whenever there's a fire alarm, the immediate response is, what are they doing in chemistry class today? Like, what's Beals doing with those kids today? That's the first reaction.
Yeah.
And to me, that's the best reaction ever. There is some validity to it, because I think myself and my students are probably responsible for over half of the alarms that have gone off in the past 15 years. But our administration is so fantastic, because nobody's getting hurt. It's just we're making enough substance that gets up into the sensor and sets it off, and we have to evacuate the school. And they're like, man, they must have been learning something up there today. Which not every teacher is going to have an administration like that. And they're like, well, hey, we have to do 10 of those a year. We'll just, there you go. Thanks, Beals.
There's one, yeah.
Yeah, there, we got that one taken care of. So I'm very grateful for that. But it happens a fair amount. I think because we're doing science. I mean, we're doing chemistry in the room. And you and I talked about, earlier that we're live right now. We're in person. Some are fully remote, but most of the students are in person. And to be able to really engage them, we've had to get creative with special masks that are non-flammable masks with special goggles. And myself and the other chemistry teacher worked really hard to make sure our students had those so that we could do science and not just have to learn about it. But not everybody's going to be in that position this year. It's a really unique time, which coincidentally, the oobleck that we just talked about and some of the other experiments that we included in the smart space are things that can be done at home. So they can be done remotely. The teacher can assign those. They can be done right in the kitchen and they're totally safe. And I think that's really important, is how can we as teachers support each other and come up with things to help our students feel like they're still doing science while they're at home.
I think that's a really, obviously the time we're in right now, that's a really important point because, like you said, some school districts, some states are doing in person, other ones they just haven't, they're not able to do it yet. They want to make sure the district's safe. And so if there are ways that students can still do chemistry while at home and do the science like you mentioned, because it is so important, that's fantastic. And speaking of which, I think that leads well into another topic. You did something with s'mores. And I guess your students, I don't know if your students online have done this one with you yet. So I feel bad giving it away, but
no, it's good. They showed up. They get to find out a little bit ahead of time just for showing up tonight.
Yeah, tell us a little bit about that. And I think other teachers that are tuning in would love to hear about that as well, because that point I think is critical, that you can still do chemistry. Your kids can do chemistry while at home. Here's some simple ways to make that happen.
Right. So s'mores are just a Montana staple. Like you go out and you have a fire and you roast marshmallows and you have s'mores. So anybody that doesn't know what s'mores are, it's time you learn. It's a graham cracker with a marshmallow that's been roasted over the fire. And that's the eternal debate. How much do you roast the marshmallow? Do you light it on fire? But we'll save that for another time. You squish that on there, and then you take Hershey's, or, people use lots of other chocolates. You put that on there, and then you squish another graham cracker on the top, and you eat it. And you're just covered in, hot marshmallow, and it's fantastic. Yeah. So one thing that we like to do is take stoichiometry, which is I call it the pinnacle of introductory chemistry. So stoichiometry, we're learning all of these things to get to this thing called stoichiometry, which is really what's happening in any chemistry environment anywhere in the world. In chemical engineering and pharmaceuticals, basically, how much of this stuff can I make and still make a profit? And how much am I going to have left over? And how much do I need to buy? And all that kind of stuff. So we take s'mores, and then we literally roast marshmallows in the lab, and we make s'mores. We take that concept and apply it to stoichiometry. How do we do that? What we do is try to figure out what our limiting and excess reactants are going to be. So I go out and purchase a certain amount of bags of marshmallows and a certain number of bars of Hershey's and a certain number of graham crackers. And then we say, okay, well, here's the mass of graham crackers that was purchased. Each graham cracker that would be used in a s'more has this mass. How many s'mores would I be able to make from these graham crackers? Okay, but here's the problem. I only bought one bag of marshmallows. So given that we can make and you can start to see how we can play with all these variables and then figure out what is a limiting and what is an excess reactant. And that's really the foundation of stoichiometry. And then you get to eat s'mores. So that's always a huge win for everyone.
Yeah, I like that smart space video, because you did a good job of saying, okay, you got this much chocolate, this many marshmallows, this many graham crackers. And how are you going to maximize the total number of s'mores you can get? And then what do you have left over? I mean, you're right. I mean, that applies in a lot of different situations, not just chemistry. So I thought that was a pretty nice activity. Plus, I'm a big fan of s'mores, and you're not supposed to light the marshmallow on fire. It's just you're supposed to toast it a little bit.
Well, that's the debate.
Yeah,
That's the eternal debate. I agree. I mean, I'll spend 10 minutes just getting that, rolling it around in
right.
the perfect. Somebody
Yeah,
said,
you
how
gotta
does
get it
one
right.
survive without s'mores? Great question. We don't. That's why
Yeah,
we
no,
in chemistry class.
all
If you
right.
are a
Well,
chemistry teacher, I use separate Bunsen burners for that lab that are just specific.
smart.
Right. Okay. So I should probably clear the air on that one.
Yeah.
Don't use your regular Bunsen burners because they're nasty.
And I guess if we're telling kids to do this at home, maybe we don't want to, maybe, if parents are there and you guys want to use, go out back or something and do a controlled little campfire, that's fine. Or another alternative is you could put the marshmallows in a bowl and microwave them until they're warm enough and gooey enough that you can put them between the chocolate and the graham cracker.
Now, I will give you, this is on topic, but a deviation from, I figured out a way to make sterno, which is gel fuel, out of vinegar and egg shells. So you can take, using chemistry, vinegar and egg shells, add some ethanol, mix it together in the right quantities, and you've got a gel fuel, which is totally safe. You light that on fire and you can roast your s'more anywhere. Like you could take it with you in your car and have a s'more like while you're waiting for the traffic light or whatever. So, I mean, if people really want to get into the chemistry, you can make the fuel that you're using to roast the s'more that you're learning about stoichiometry with.
That's pretty wild.
I think that's like a perfect world.
Yeah, because the alcohol has such a low burn point, I guess, that you can do that.
Yeah.
Okay, I guess we better transition away from s'mores, but not quite out of the kitchen yet. You did another one of these videos, and I can tell I would have loved to have had you as a teacher in high school. You're great, because you did another one where you taught the kids how to basically make an Arnold Palmer.
Yeah.
So tell us a little bit about that whole lab.
Yeah. So an Arnold Palmer is tea,
Lemonade and tea.
lemonade and tea. Yeah. And what I really wanted to do last year when we went remote was have a way that students could do an experiment with acids and bases that was completely safe. And if we can think of an experiment that students can do at home that they can eat or drink, that's a win-win, because who doesn't like to eat or drink, And,
right.
And most of the experiments that we do in the classroom, you can't, like we've got every safety protocol you can imagine. There's no eating or drinking any of it. So what I decided to explore was taking something called butterfly pea tea. So butterfly pea is a pea, the pea plant, but when it blooms, it's got a bright blue flower. So over in Southeast Asia, they dry that flower and turn it into a tea. So the tea then is bright blue. But I don't know how this hasn't caught on. I don't know why there isn't any tea that is not colored blue anymore. Because it's the coolest. There's no reason tea shouldn't be blue anymore with these flowers.
It's way better than brown. Yeah.
Yeah. I mean, and it's like a very pretty blue. So you make this, but as you add something that's acidic, it starts to change the molecules slightly, which is what we talked about in the video. So in that lesson, really the point is exploring how those acids and those hydrogen ions change the molecule. And when it changes the shape of the molecule slightly, it absorbs light differently, which means it's going to look a different color. So you can change the color of the butterfly pea tea by adding something acidic to it. And lemonade's the perfect thing. So adding a little bit of lemonade to that in different amounts will actually change the color of the tea. And my students from last year can tell you, if you don't add the lemonade, it's not the best tea in the world. So it's kind of earthy.
Yeah.
Put it nicely. So you got to have, then you can change the color. I mean, you can make ice cubes out of the tea, add it to lemonade, and the ice cubes, the color will change as it, just all sorts of cool sort of fun experiments you could do at home with acids and bases and this thing called butterfly tea. You can do the same thing with red cabbage juice. In fact, red cabbage juice is even better. It's more brilliant, but it's really bad to drink. It's
Yeah.
just,
Yeah.
it might be really good for you. I don't know, but it tastes terrible.
Sure.
So.
Yeah, it sounds like it tastes terrible. Haven't had any of that. But, I feel like we're kind of on this kitchen theme, this eating and drinking chemistry theme. And there was a question in the chat where I guess some of your students wanted you to share something about a hot dog experiment that turned into chalk. You stuff in your chemistry class, Craig.
So, okay. I think I know what they're talking about. I'm trying to look at my other screen over here. Well, okay. So every year, the first day of school, I think the first day of school is the most important day of the year. I really do. And you got one chance to make a first impression. And I manage to screw it up every year, but that's kind of my thing. So, but I think it's so important in science to set the tone and really just to blow stuff up. So I also get liquid nitrogen because most people haven't gotten a chance to really interact with liquid nitrogen. So first day of school, blow stuff up, make sure there's liquid nitrogen, capture their attention, and then make them miserable for the next 9 months learning, math. That's my goal. But the liquid nitrogen, I usually take a banana and put it in the liquid nitrogen and freeze it and then use it to hammer a nail into a board. Kind of a classic. I didn't invent it. Classic thing. Well, I went to Walmart this year, and apparently COVID has caused a shortage of bananas. I don't know. But the night before the first day of school, I'm like, there's no bananas. You can't find bananas. So I went with the next best thing, and that was hot dogs. And I don't know. I was like, because I've never frozen a hot dog in liquid nitrogen. So I brought in the hot dogs, and we put the hot dog in the liquid nitrogen, and it obviously turns solid. And I was able to hammer the nail in, but it shattered into pieces. And then the students in first period, I think suggested, well, you should probably eat it. And I was like, I guess probably should. So I ate the hot dog, and it was like chalky bologna meat jelly that was dehydrated. I don't know what it was, but it was not good.
Yeah. I've always heard you're not supposed to ask about what hot dogs are made of. So
right. Yeah. And as it kind of melted in your mouth, it turned into liquid meat. It was, there might be a place for this somewhere in some culinary thing, and then of course, so I had several students that wanted to try it as well. And after we talked about the safety of that, some of them did try it, and they agreed with me.
So nitrogen frozen hot dogs and a little bit of cabbage juice along with some butterfly tea.
Yeah.
Beautiful.
Basically the most disgusting class in school.
Yeah, I was going to say the only good thing are the s'mores. I think that's the only thing so far where I'm going, all right, I'm on board. I've got a question for you. Now, I want to, so for other teachers that are listening into this, do you make up your own experiments or do you find them from other teachers or?
I am a quintessential teacher where even if I think I probably came up with my own great idea, I probably stole it from somewhere and don't remember where I stole it from. And, just especially when you're first 5 years of teaching, you're just looking for any resources you can find. And from that point, I have adapted everything into my own stuff. But as far as a new and novel idea, I don't know that I've had one. I might think that I've had one, but it might have been inspired by something that I saw somebody else do. And really that's my goal. Like somebody doesn't need to credit any of the stuff from me. I want teachers to do this kind of stuff with their students. That's really my goal, because they should look at their teacher in the front of the room and be like, that person just ain't right. Like that person is crazy. And then when you get to stuff like dimensional analysis and they're going, oh my gosh, the slog, they're like, yeah, but that crazy person might just do something ridiculous. So I'm going to stick with this class and pay attention just in case something weird happens. And, that I think we have a real good opportunity in science to do that. It lends itself to doing exciting things every once in a while with young people. And there's no reason learning shouldn't be fun. I mean, it doesn't mean it's going to be fun all the time, but there's work to be done, but there's no reason it can't be fun.
Yeah, I love that. And I agree with you 100%. Science should be fun. It should be, all the subjects are great, and history and language arts, they all have their sort of moments, but science is like, it's telling you how everything works around you. It's sort of revealing, the mechanisms of how nature works. And that alone is just something awesome. But I will say this, I don't think you're giving yourself enough credit in terms of, whether you invented it or not, because, necessity is the mother of invention. We've all heard that. And so just like you ran into your banana issue, you went with the hot dog instead. You could be the first to freeze hot dogs with liquid nitrogen and hammer a nail with it. So you're
that's quite the
ground here, Craig.
Yeah, that's quite the claim to fame, I guess. I'll take it.
Yeah, there you go.
Maybe I'll get shirts printed up.
Yeah, that's a good idea. I saw some of your students are chiming in. Your student Allison said that she really loves the first period class. Not sure if it's Sire Green or Sear Green. Said chemistry was definitely the highlight of the first day of school. So the fact that your students are on here, sort of singing your praises is a testament to what you're doing and pushing boundaries and trying to figure out new ways to get kids engaged. And honestly, a lot of people feel like chemistry is a tough topic, a tough subject. And so it sounds like you're doing a lot of cool things. And I love it that also you're open to going out to other teachers and learning from them and sharing information and sharing how to get things across to kids. So, and like you said, that's what it's all about. So I think that's a really cool thing that you're doing.
Oh, thank you. I think we have a real obligation. We have an obligation to our students. I don't tell them this, although apparently some are listening, but I don't work for the city. I don't work for the school. I work for these kids. Like, I see them as my employer, and I need to do what's right by them. Now, they may not see the end goal in the same way that I do, but my job is to show them that end goal and show them the purpose of this class. And so many of them they're not going to grow up and be chemists. And I tell them, you don't need to grow up and be a chemist. Why are we in this class if you're not going to grow up and be a chemist or a chemical engineer or a doctor or a nurse or whatever, where you really got to have a good understanding of chemistry? And I tell them, well, the thing is, you're learning how to learn, and you're learning about the basic pieces of matter that make up everything around you, like everything around you. And all these bits and pieces of abstract stuff that you're learning about come together in something really concrete that we call life. I mean, we're made up of all those bits. So if you don't understand what any of those little bits are, you don't really understand yourself or what you're made of. And I feel like in science, the more you learn, the more it spurs your curiosity. Like, the more you learn, the more you want to kind of get a hold of more. And so I tell the students, that's what we want to go through this year. We want to learn more and more and pique your curiosity and see if we can't, get you to appreciate all these bits and pieces that you're made of and appreciate this life that we lead. And I think chemistry and the sciences can really help students see that.
Yeah, that's powerful. Yeah, I agree. I couldn't have said it any better myself. That was good. Well, Craig, we're coming up on the end of this session. Unfortunately, it kind of flew by for me.
We had
a lot of great conversations in the chat. I know you have a social media following. Do you want to let anybody know that's watching right now what your social media accounts are?
Yeah, on YouTube, it's Beals Science on YouTube. It's lessons and experiments for teachers to share and learn from and students to watch, and I'm blowing stuff up. And then I've got all my lesson plans for every experiment that I do over at bealsscience.com. There's no advertisements. Everything's completely free. It's just part of what I feel is my obligation, not just to my students, but to also help other teachers that might need resources. I think we as teachers need to do that for each other. And so everything, I put it all over there to try to help other people out, and they can just steal everything that they want and make their class fun and engaging for young people.
How long will it be before you post the hot dog lesson?
I don't know. I got to figure out something really cool to do with that. Maybe shoot it out of a cannon or
Yeah, there you go.
flaming
Well,
hot dogs. We'll figure something out.
yeah, there you yeah, I have no doubt about it. Craig, this has been great. We're out of time. But I want to let folks know that are watching, we're doing some more of these Q&As based on the Smart Space Science video series over the next couple of weeks. Just if you go to TI Calculator's YouTube channel, you'll see when those are up and coming. You can set a reminder, and that way you'll know it'll pop up when we're live. And check us out at TI Calculators on YouTube. There's a bunch of science videos as well. With that, I think we're done. And Craig, good luck in the rest of the school year, and I'm sure I'll be talking to you soon.
Well, thank you. And thanks to everybody that chimed in. I appreciate it.
Bye, everybody. Have a great day.